In this video, we're going to be addressing scientific notation, and first is given the following question: convert the following numbers to scientific notation, where for A you have the given number 5,400 and the other number is 0.0000653. How we're going to express these numbers that are given in standard notation to scientific notation. What I want you to do is pause this video, try and solve this question, understand what scientific notation is, and once you're able to understand that fully, then solve this question and check the solution after you play the video. Understanding how to get to scientific notation from standard form, we recognize that standard form shows you all the digits that makes up that number, either this particular form which represents very large numbers, where for large numbers it's considered to be numbers that are greater than 1 on your number line or less than -1 on your number line. However, on the other hand, for numbers like this, which we represent also as standard form, we see that this number is really small, and this particular type of small numbers are found either between 0 and 1 or 0 and -1. And so once you're able to recognize these types of numbers in terms of scale, how heavy or large those numbers are or small those numbers are, it's going to be difficult to show those on paper because paper is limited. And so to simplify those forms, what we do is that we are going to be transforming from our standard form all the way to scientific notation, where we'll be using one instrumental power, which is what? Powers of 10. And so on the other hand, going from scientific notation back to standard form, we are going to be applying the operations that is necessary for we to get to standard form. In this case, we are going to be multiplying by the result of whatever 10 to the exponent that we have above, and your decimal that is always between 1 and 10. For strategies, here are 3 steps to be aware of when it comes to developing your scientific notation. The first step is to what? To locate your decimal point. The next step is what? To locate the first non-zero digit. And step 3 is what? To move whichever direction you're going, your decimal point 1 digit at a time to arrive what? After the first non-zero digit. And how this looks like is what? Based on this result. For our step 3, if we are moving from right to left, we are performing a positive action. However, if we are moving from left to right, we are moving in a negative action. This results in the following: times 10 to the power of whatever steps that you took, either in the positive direction, going from right to left, or negative direction, from left to right. How does this look like? This looks like this on the right side, alongside multiplying your 10 to the exponent number by what? A decimal that is between 1 and 10. And so we're going to apply this strategy to not only our question A, but also for B. Now, applying this to this question, in here, the first question you should ask yourself is this a whole number or a decimal? We know that yes, indeed, this is a whole number. Therefore, our decimal point is nowhere other than at the extreme back of the number. So we're going to put our decimal point right there, and once we place it there, we can now begin moving our decimal point where is dependent on the next step, which means we have to first locate our first non-zero digit, moving from left to right. And moving from left to right, we see that our first non-zero digit is 5, and therefore we're going to highlight it right over here. Our next step, which is step 3, is to move our decimal point how many steps to the back of our first non-zero digit, or moving our decimal point how many steps after our non-zero digit. Therefore, our movement shows that we are going 1, 2, 3, and in here this implies that our multiplication by the 10 to the exponent is going to be what? We have times 10 to the exponent is 3, because that is the last number of step that was made by the decimal point before it hits after the first non-zero digit. Therefore, we are having our value to be a positive 3 as the exponent, because we are moving from right to left for the decimal point. Now, once we have this, our final result is going to be the decimal that is between 1 and 10. And in this case, our new decimal point is going to be located right here between 5 and 4. Therefore, we are going to have our answer to be 5.4. You can put the zeros after. However, since there are zeros that comes after and there is no non-zero digit after the last zero, then it means that we are going to be removing that 0, and it would just be 5.4 times 10 to the power of 3. So this is our answer to A by following these steps that is necessary in order for we to accomplish our scientific notation. We are going to try now B. Finally, we are given a small number that is 0.0000653, and we're going to convert this to what? To standard form. In order for we to accomplish this, all we have to do is follow our first step, which is to locate a decimal point, which we have located it to be right here. And then our next step is to locate our first non-zero digit, moving from left to right. And so moving from left to right, we see that there are zeros. Bam! We have our 6 to be our first non-zero digit, and we're going to highlight it right over here. Our next step is to move our decimal point one step at a time to arrive after our first non-zero digit. And recognizing that means that our decimal point is going to be moving in what direction? Not to the left, because that is not where our first non-zero digit is located. However, we're going to be moving to the right, and that means that we're going to be going one step at a time, negative numbers. And so we are now going to be counting -1, -2, -3, -4, and after the first non-zero digit, which is now -5. And this here is going to be expressing our 10 to the power of what? -5. So we are going to multiply 10 to the power of what? -5, which is the last place value movement that our decimal point made after our first non-zero digit. And so we're going to write -5 at the top, And finally is what is the decimal that is between 1 and 10 that we're going to place right here. And that number is from the first non-zero digit onwards is what we're going to place our result here. But take note here that there is our new decimal point that is going to be placed right here. Therefore, we're going to start with 6, and then you have your 0.53, and this here is our final answer. 6.53 times 10 to the power of -5, and this is the scientific notation for this question that was given. You can also go backwards by punching it into your calculator or doing the reverse of what you have here. And doing the reverse includes the following. We can see that yes, we have -5 and we have our decimal point, which means that here we are going to recognize that going back to standard form, we have -5 as our exponent. We're going to move our decimal point in the reverse direction, which is, in this case, we're going to count 5 steps now to the left. So we're going 1, 2, 3, 4, 5, and that means we're going to fill that out with zeros. And so we're going to have a 0 in the spaces here, and where our arrow stopped is where we're going to place our point, and we're going to put our 0 right there. Therefore, our new result, which is going from scientific notation back to standard form, includes the following. We have this 0 point, we have 0, 0, 0, 0, 6, there's no more decimal point, 5, 3, and this here is eliminated because this now shows you the action to take to get back to standard form. And so this is our final answer in terms of converting from scientific notation back to standard form. Now for a question where we're able to determine the scientific notation, we're asked to convert to what? Standard form. And in order for we to accomplish this, all we have to do is remember that we have to eliminate our times 10 to the power of 3 based on the exponent, and the exponent here tells me that for 3 I have to do the reverse direction by moving our decimal point not to the left but to the right. And what that looks like is that we're going to write our what? Decimal, which is between 1 and 10. In this case it's 5.4. We're going to write it down here, and what you're going to do is move your decimal point not 1, not 2, but 3 steps to the right. And what that looks like is you're going to have a decimal point which you located, move 1, 2, 3, and so our new position for our decimal point is going to be right here. And remember that this decimal point that you had initially is going to be eliminated, and you're going to have what? You filling out the space with zeros, and what that looks like is the following. We're going to have our final answer to be 5, 4, 0, 0. Point what? Yes, you can put a 0 here as well as what you have right here, but any number 0.0 is the same thing as this number, and so in this case you can just eliminate that decimal point because we don't need it at all. So our answer is now back to how it was before, which is in standard form 5,400, and we are able to not only do that for large numbers, but also we're able to successfully do it for small numbers. Remember also that you can try this for any question, And so what I'm going to challenge you to do is to do this for 8. We have 7200000. Let's put it that way. And for B, you're given the number 0.0000528, and your goal is to convert to scientific notation. And finally is, once you're able to do this, you will also try to convert it back to standard form. And I hope that this will shine a light on how it's really important to know how to do both converting to scientific notation and to standard form. Thanks for following me through this. See you on the next one. Stay smart as always and believe in yourselves.